All right. You can remind me to turn the recording off when you're done. Yeah. I had a 5-hour video. I forgot to not record it. And I don't want to edit it. It took like a day to process it and then ship it to me. I'm like,
It would take 10 minutes to edit that.
yeah, if you, or an editor, but if you're not an editor.
Even if you're not an editor, pop the thing in iMovie and then just put it in a 5-hour movie.
I know, but then I gotta,
You're right.
I gotta download it to something else. Not the way this thing functions easily. All right, hey, here's a really common AP question. I can't think of a test where I did not include this on there, hint, hint. But AP loves this question as a multiple choice question. And the idea is you've got a guy walking away or walking towards a light post. And I don't know if you were ever a little kid. I can remember being a kid. We used to go to this restaurant called the La Romantica. It was in Germany when I lived there with my dad and mom when I was really young. And you'd walk down this alley that had these street lights. And I remember as I walked, I could see my shadow. You know, I was like 5. But I remember seeing my shadow, you know, like when you're walking away from a light, it grows. You follow me? Okay, so what's happening here is this guy's walking away, but we're talking about his shadow. So as he walks away, as the light shines down on him, which it's shining in all directions, but I kind of showed, or they showed, the shadow right here. The shadow is going to be growing, right? Because the light is kind of hitting the back of his head, right? And it's lighting him up, but it's casting a shadow right there, right? And as he walks further away, like hypothetically, as he walks further away, you know, when he's here, whatever. As he's here, you can see his shadow has grown, hasn't it? You with me? So as he's walking, the rate at which things are, there's some things that are changing, right? So this is a study on these rates. So I'm going to go back and just draw this, but this is the way you have to think. So as he's walking, is the light post height changing? Is his height changing? So those are fixed amounts, right? Is the distance between him and the light post changing? Yes. Is the length of the shadow changing? Yes. So those are the variables that are in this situation. You really don't want, now granted, the length of the light is changing too, but you're going to see that's not talked about, right? So if you want to start labeling stuff, I would probably say, okay, I'm going to call maybe that X and that Y, but it doesn't really matter what variables you use. Do you have a question?
Yeah, the speed of the person change.
Yeah, and I haven't even started reading it yet. I guess I should read it, but yeah. So right here it says a person whose height is 6 feet, so I know that their height is 6, is walking away from the base of a street light along a straight path at a rate of what? 4 feet a second. So what am I giving you when if you've labeled this X and Y, right? What is changing? dx, dt. Y'all see that? Now, it doesn't matter what you label these things, but as I walk away, if I'm walking away at 4 feet per second, this is what's changing at 4 feet per second. Does that make sense? So my dx dt is 4, and if I was walking towards the street light at 4 feet a second, that would be shrinking, wouldn't it? So I would have to say -4. So AP will get them walking either way. You're going to see another one later on today or tomorrow, or the next day or whatever, that's going the other way. So make sure you that you account for that. If it's away, it's getting bigger X, positive, it's smaller X, negative. All right, and then it says if the height of the street light is 15, so I can go ahead and put that in there. That's a fixed amount. What is the rate at which the person's shadow is lengthening? So what did they just ask for? The dy dt. Now, most people on their test get this. What they don't get is the equation they're going to use. So I have to have an equation that includes X and Y. Now, this is all geometry right here. Can you guys set up an equation that it relates the X and the Y here? Close, unless I didn't hear you right. You said 15 over x plus y. She's saying this triangle is proportional to that triangle, right? So this triangle, side over side, and the length of that side would have to be the sum of those, is proportional to this triangle, right? So 6 over y. This goes back to just proportions like you did, like to take a little sidebar here. Do you remember you'd have stuff like, all right, if that's a 30 and that's a 60 and that's a 90 triangle, you know, you knew the proportions of those. You knew that this was like 1, 2, square root of 3. And you'd say, okay, well, what happens if you have a 30, 60, 90 whose little short leg is 0.3? And you wanted to know that leg right there. You would do stuff like 1 over root 3 is 0.3 over x. You remember doing those proportions? That's all you're doing here. But you just got to make sure when you set this up, you label those variables. And it's not the only way you can label them, and this is just the easiest way. And also, if you're kind of thinking ahead, you could say x plus y over 15 equals y over 6 if you wanted to. And that way your variables would already be in the numerator. It doesn't really matter to me because the first thing, I'm not going to differentiate that. I mean, I can, but then I got to do quotient rule and junk. Why don't you just cross multiply and clean it up a little bit? So at this point, before I even get to the calculus, I'm going to cross multiply and get 15 times that y and 6 times that x plus y. And then I can even clean up that more, right? Subtract the 6y over. And I can even clean up that more if you want to, although at this point we're just I don't know. I can if I want. So how about 3y equals 2x? Now, once you get it as clean as you want, then the process of taking the derivative comes into play. And this is probably one of the easiest ones you'll do, right? The derivative of that is 3 dy dt equals 2 dx dt. And you're good to go, right? We didn't need to make any substitutions here because the only variables were x and y, and I knew one rate and I wanted the other. So we're just plugging in dx dt is 4 and solving for dy dt, and we get 8/3. And what is that? Y is feet per second. So according to this, what, 2 2/3? Looks like 2 2/3 is. This has been a calculated problem, I guess. Not that you really needed it. Are y'all seeing that? Know how to do this problem. I mean, it's just too common a question. And these multiple choice questions are like 1.2 points apiece. They're just little ones that aren't that tough, but you got to know how to set them up. A lot of people do this when they go to set them up. They do stuff like 15 over x equals 6 over y. That's probably the most common mistake I see, because 15 over that isn't proportional to that over that, is it? So make sure you get that proportion right. And this problem really, again, you could take the derivative here. You could. I don't really want to. You could even solve for y completely right here and say y is 2/3 x and then take the derivative. There's lots of different things you can do. That's something we haven't done a lot of, is actually solve for the variable we want to take the derivative of. But anyway, so that's what I wanted to look at. Also, I'm going to come back. That was page 62, I think. I want to come back to 61. This was an old AP question as well. AP, by the way, now only has 4 options, A, B, C, D. So it's a little easier to guess. But on the flip side, the scores have tended to trend up a little bit. So where it used to be like a 70, now it's like a 72. So to get whatever it is you want, the score you want. But anyway, what did they give you there in the first part of that question? They give you some weird equation that included a what? A dy dx. So if I wanted to, I could solve for that dy dx, and I would have what? What would I have if I just solved for dy dx? Okay, no, yes, but I mean, like, what is that? That's my slope. That's my derivative, right? So they included it in there, which means if I go ahead and just solve by dividing by x plus 2y, I've got the derivative. Sometimes literally the question will be, it'll be find the derivative dy dx at the point 3, 0, and they'll give you this little deal here. If I just divide, that's my derivative. But this thing said find the what? The second derivative. So I could take the derivative here and go first d second plus second d first, and then take the derivative, but it just becomes very messy to me. So if I'm ever going to take the derivative, I like to go ahead and have the first derivative solved for, and then take the derivative to get the second derivative. So if that's the first, okay, I'm going to come over here and say, all right, the second derivative, d2y over dx squared, is what? How do I find it? Low to high, right? So low times the derivative of the high. So what do I get when I take the derivative of the high part? I get what? 2 minus dy dx. So I get 2 minus 1 dy dx, or just dy dx, and then minus the high part times what? 1 plus 2 dy dx. Are y'all all seeing that? And then all over the low squared. Now, my key, the form is not great, it's not wrong, but I say something like the question is not to find the second derivative. It says find the second derivative at that point. So what I said was, at the point 3, 0, the second derivative is a better way, and I want you to have better form than my old key that I did a zillion years ago. And I'm going to try to rescan. I redid it. But what I want you to be able to write is, hey, the second derivative of y with respect to x, draw a vertical line, and then the point 3, 0. And then put equals. It's kind of like f of x. When you have an f of x function, when you write f of 2 in there, this is how you do it with a derivative. Or you could say, this is kind of annoying. If I was writing it like this, the second derivative, we usually don't have a place we usually don't write functions like that, right? So to me, it's better or more appropriate to write it with that little parentheses down there at the bottom, or the point down there at the bottom. Now, what problem do I run into as I start plugging in 3's for x's and 0's for y's? I run into the dy dx. Well, the dy dx is what? This. And so when I have two options, remember, this is a multiple choice question, so I don't have to show all my work. Now, on your test, you do, because I'm giving you points for all those things, right? I'm not just going to give it right or wrong on a multiple choice. You can be wrong and still get most of your points. I'm just trying to get you used to seeing multiple choice questions, right? So what I need is, I can, if I want, plug that in right now. I don't really have to simplify it. Or I could just come over here and find the first derivative at 3, 0. And then anytime I need it, I can just shove it in there. So I think that's a little easier for me. So I'm going to plug a 3 in there and a 0 in there. That gives me 2 times 3 minus nothing. And then I'm going to plug a 3 in there and a 0 in there, right? And those zeros don't really do much. And I get 6 over 3, which is 2. So I'm going to use a 2 every time I plug that in for dy dx. Y'all seeing that? So here we go. Plugging a 3 in there, I get 3 plus 2 times 0 in the first parentheses. The 2 times 0 goes away. The second parentheses, I get 2 minus 2. And what does that do? That just blows that whole thing out, doesn't it? Because 2 minus 2 is 0. Everything connected it's a 0. And then I get minus 2 times the 3 minus 0 times 1 plus 2 times 2. All of that over 3 plus 2 times 0 squared. So just be really careful. At this point, I get what? 6. That's a 5. So I get a negative 30 in the numerator. And I get a 3 squared, which is 9. So you get negative 10 thirds. And you should be able to find that answer. Y'all with me? So remember, this test is not just on all the related rates. Don't forget the implicit stuff, finding the second derivative. Remember, anytime you find the second derivative, you almost always are going to have to go back and use the first derivative in there. But if this was a free response question and they had just said, what's the second derivative? Then I would have actually taken this and I would have plugged it in there and tried to clean it up a little bit if that was a multiple choice question. But the fact that they're only asking for the second derivative at a point, well then make your life easy, right? It's a pain to rewrite this thing with that fraction shoved in there. I don't want to deal with that, right? So just use it. Go ahead and find that value because you're going to end up plugging. If I did plug it in there, wouldn't you plug a 3 in for each x and a 0 in for each y? Yeah, so go ahead and do it early, and then you can just plug a 2 in there when you end up doing the derivative. Tracking with me? Okay. What about, how about this? So AP multiple choice. I don't know what, I guess it was number 4 on some tests. I don't know why I didn't put the year there. So let's take a look at it. Another 1.2 point problem. What is the slope of the line tangent to that curve at the point at which x is 1/4? So what am I asking for when I say what is the slope of that line? What is the derivative? So if I take if I have y equals arctan of 4x, I'm ddxing that, aren't I? So I'm ddxing that. What's the derivative of y with respect to x? dy dx. What's the derivative of arctan of blah? And again, these are the easiest questions on the planet if you know your formula. If you don't know your formula, I guess you could go back and think through what we talked about with inverse functions, but that was kind of ugly. It's not 1 over, it's the derivative of u, because when you say that first, you're really doing the chain rule. The chain rule says times the derivative of the blah, but we always put it on the top. But yes, that's the u, and the derivative of that is a 4. But the formula for arctan is what? 1 plus the u squared. And again, this is implicit, so remember I got to do what? dx, but it doesn't matter here. Because I wasn't taking the derivative with respect to time, right? This is just a regular old function. So I don't need the dx on this because it would have canceled. And then it says, all right, now that I've got this equation, this slope, I want to find the derivative where? At x equals 1/4. Now, if it's not a point, then write x equals 1/4. But if it's a point, some people literally write parentheses xy equals the point. I don't think that's necessary. A lot of books don't do that. It's just excessive. But here, you want to make clear what you're actually plugging in. So if it's a value, say the value that you're plugging in. If it's not, if it's a point, right, you can write the point. So here we go. 4 over 1 plus 4 times 1/4 squared. So I end up with 4 on the top. What's 4 times a 4th? 1 squared is 1. 1 plus 1 is 2. And I end up with a nice solid 2. I do as well. But guys, if you don't know your formulas, you're dead. What's the arc sine formula? What's the derivative of arc sine of u? What is it? The square root of 1 minus u squared. What if it's arc cosine? Put a negative on it, right? What if this is arc cotangent? Put a negative on it. What is the derivative of arc secant of u? Still u prime, right? Take the sine part and do what? Flip it. And what goes out front? Absolute value of u. Good. And then what do you do if it's arc cosecant? You got to know them. You don't have to know them. There's ways to get around it, but it's not fun at all. But you can. But it ain't fun. Especially if you don't have a calculator. I mean, some of the ways to get around it are a lot more doable with a calculator. Radius of a sphere. And again, a sphere does not have a continuous cross-section, so you don't have to know that volume equation. So that would be given to you if you needed it. This one's talking about the surface area of a sphere, and notice they gave that to you, and they said S, surface area S. So they're calling S, you need to call it S. And again, on the multiple choice, it's not going to matter on the real AP test. You can scratch all you want. All they want is a correct bubbled-in answer. But on my test, even if it's multiple choice, show it to me, because this might be a 5-point problem, and I'm going +1, +1, +1, +1. If you miss it, and I can still give you partial credit. So anyway, it says the radius of a sphere is decreasing at a rate of 2 centimeters per second. What is that? Good, dRdt. So I've got dRdt is what? Good. -2 is decreasing. At the instant when the radius of the sphere is 3, so when r is 3, what is the rate of change of the surface area? What is that? ds dt. So I'm looking for the rate of change of the surface area when the radius is 3. So, am I going to be good with this equation right here? And you'll see most of the time on the AP test, on multiple choice questions, there's not a lot of substitutions to be made. I mean, it's pretty straightforward. At least recently. You go back to the 70s, not so much, but in the 70s, they were just beating you to death with algebra. I mean, really. I look at some of the, well, I didn't have a graphing calculator, so you just spent more time with algebraic stuff. You couldn't explore as many things without a calculator. So when calculators came around, we're like, oh man, that just opened the doors to other things that you could look at. So they're like, all right, well, and you see it in pre-cal. I mean, if you're in my pre-cal class, we use calculators a lot, but maybe not even as much as regular pre-cal. And I know in my Algebra 2 class, we hardly use them at all, but a regular Algebra 2 class, you probably use them more. So it's just more of a calculator-based work because you can do more. You can look at more stuff. But anyway, taking the derivative, what's the derivative of S with respect to time now? And what's the derivative of that expression? 8 pi r to the first, but don't forget the RDT. And at that point, you're looking for this, you're just plugging and chugging. So once you plug everything in there, you see that the surface area is actually becoming smaller as my radius decreases, right? So -48 pi. So pretty straightforward. A lot of these problems on the, sorry if I erased that too quickly. A lot of these problems on the AP test really aren't that bad. Here's one walking towards the post, right? So the only thing you know now is this rate is getting smaller, the shadow's getting smaller, so you have to have a negative. I'll leave that to you. How about this? This is 1972. I was 5. Some of your parents weren't born. Calculate the first and the second derivatives. So let's talk first derivative right here. It says with respect to x. So what is the derivative of y here? dy dx. What's the derivative of 2 blah? 2 times e to the blah. What's your rule for taking the derivative of an e? Copy it all down, good. And that takes care of the 2 and the e. Then the derivative of the cosine is times a negative sine of x. All right, that takes care of the cosine. And then the derivative of the x is 1 dx dx. And we don't need the dx dx. Now, I'm a fan of cleaning stuff up if I'm about to take a second derivative of it. So if it was me, you don't have to, but if it was me, I would say -1 times 2 is -2 e to the blah sine of blah. Now, if that's the first derivative, what do I have to do to find the second derivative? What do I got going on? Huh? Product rule, right? So again, I like grouping the the constant out front, the coefficient out front, I like grouping it with the first number. To me, it's just easier, but if you'd have left it right here, if you'd have started doing the quotient rule with this, that's fine. It'll work out in the wash. It'll be fine. So I'm going to go first. D second is, hold on, derivative of the sign, just regular cosine, plus second times what? D first. And on the D first, I'll go ahead and put these in parentheses. Kind of on the D first part, I'm going to copy it down. And then what? How do I take the derivative of this part I'm underlying heavily? Copy it down. Multiply by the derivative of that, which is another negative sine of x. And now I'm probably going to want to clean this up a little bit if it was a multiple choice. So I look at this and I go, all right, I got a negative 2 e to the cosine x cosine x. And then what do I have here? Hello? Hey. Sure.
I love it.
Called me in first period. Would you post attendance? I was like, I did post attendance. Oh, sorry. It just turned into attendance. You should just go no and hang up on it. You get ornery when you get older.
You get what? Ornery.
I say ornery. Is it ornery?
I'm
going with ornery.
Wait, what? Wait, because I've always heard that age of silence.
She's got California roots.
Ornery? It sounds like a French version. Carol?
Oh.
Horrible. What is this? Wait, what word is this?
Her dad's from Chico. What do they know out there?
Ornery?
Four, we got everybody else? Nope.
What does it mean? Crank?
All right.
Never heard that word before in my life.
What word?
Ornery?
Okay, so, ornery?
Yeah, never heard that word.
Learn, expand your vocab. All right, so right here, guys, I would probably do this. These two negatives made a positive. And then I would probably write this as 2 e to the cosine x sine squared x. But I can tell you, even though it doesn't mean it's simplified, if this was an AP question, they're always trying to do just some little thing. Simplify, if you remember, means PEMDAS, right? There is no F for factor in PEMDAS at all. It's not PEMDAS at the end, right? But nevertheless, AP, a lot of the time, will go over here and they'll go, you know what? We're just going to factor out a 2, an e cosine x. And we're going to take that out. And we're going to leave this as sine squared x minus cosine x. You see what I did? So they'll do that, right? If I take that out, I'm left with a negative cosine plus sine squared. So they'll do that a lot in a multiple choice question. If it's not multiple choice, don't worry about it. If it's not multiple choice, you can leave it like this. There's no rules for simplifying on this. You can leave it as literally, as long as you've got the second derivative on one side, it doesn't matter what you have on the left. But this is a very common looking, not in this case, this is for response. This is probably a 3-point question. And you would have been fine stopping right here. All right? But on a multiple choice, probably would have looked like that. And maybe because, you know how when you're finding derivatives, you're always using them to find critical numbers and inflection points? So you're factoring it. So that might be part of the reason why they do it. It's like, oh, well, you know, I might have needed to factor that. So a lot of times they will factor it. But again, that's not something you would need to do. That's just something if you saw this as an answer and you had this, don't go, oh, E, none of these or whatever. Just think, wait a minute. Let me go take a closer look at what I have, see if it actually matches that. All right. Oh, second question. If x and y both vary with time in such a way that y increases at a steady rate of 5 units per second, at what rate is x changing? Okay, so what did they just introduce into this? Time, didn't it? So on this problem that I just erased, okay, so I'll go back to what I had. So I had the second derivative equals 2e cosine x sine squared x minus cosine x. Okay, so it said if x and y both vary with time in such a way that y increases at a steady rate of 5 units per second, what are they giving you? dy dt, good. Increases positive 5. So if they told you that, and they said, at what rate is x changing? So what does that mean though? I don't know.
I don't know.
What is dx dt when x is pi over 2? So you have an expression right here. And by the way, I don't even need that. That's the second derivative. I've got to go back to what I had for the first derivative. So dy dx was 2e cosine x negative sine x. Is that what I had? Wait a minute. No, I don't even need that. I need the original function. So I need to go back to this original function, y equals 2e to the cosine x. Because I don't want the derivatives with respect to x. I want the derivative with respect to what? T. So I go back to my original function. I take the derivative again. Now, is this derivative right here, right there, going to be really any different from this thing if I dy dt it? What do I have at the end? A dx dt. This one didn't have a dx dx on it because it would have canceled. But now that I'm taking the derivative with respect to t, dy dt equals, copy it down, the derivative of the top, negative sine x dx dt. So they kind of talked about derivative with respect to time. Remember, we don't have to write that on a first derivative, dx dx, because it would have canceled, because I'm taking the derivative with respect to x, but now I need it. So basically, if dy dt equals 5, when x is pi over 2, I can just plug in pi over 2 everywhere. Good thing we know our unit circle perfectly. So what's the cosine pi over 2? 0. So cosine of pi over 2 is 0. E to the 0 is 1. 1 times 2 is 2. So all of that cleaned up. And what's the sine at pi over 2? Sine at negative, actually negative sine of pi over 2. Sine of pi over 2 is 1. Negate it becomes a what? So I get a negative 1. And then that negative 2 divides and you get negative 5 halves. So you end up getting dx dt is negative 5 over 2. And it's a fairly common thing for AP to sneak a question in like that on you where they go, oh, take the derivative with respect to time. And you're seeing y's and x's and you're so used to it you forget that part. And what they normally do is they give you 1 point for finding the derivative and 1 point for remembering that. And then, of course, if you don't remember that, it's really hard to solve for it, right? So that becomes a problem. What else? Oh, yes, the old angle of elevation problem. We haven't done a lot with angles. So let's take this. This is a pretty common AP or test question. Again, it'd probably be a multiple choice right here. So check it out. And make sure you draw a picture of this to think about it. A balloon rises at a rate of 3 meters per second from a point on the ground. So I'm starting to visualize this picture. All right. So a balloon is rising from a point on the ground. Right. Here's a balloon. Maybe it's a hot air balloon. We'll make it interesting. Okay. So a balloon is rising from a point on the ground that is 30 meters from some observer. Okay? So from a point on the ground 30 meters away. Find the rate of change of the angle of elevation. Now, do you remember what angle of elevations were? An angle of elevation is always, or depression is always measured from a horizontal. So you're basically saying, if I'm looking, I'm saying, what is that angle? I'm elevating my angle to look at it. So this observer right here, what is that angle of elevation? That's what I'm dealing with. So when I think about this, yes, I have a line of sight that has a length. I don't think that comes into play here. There's a height that is changing, but this is not changing here, is it? So when I think about a formula that I can use here, I certainly want to include these variables, but I don't want 30 to be a variable. I'm not going to call that base or x because it's not changing. So can you come up with something that includes the theta, the h, and the 30? Okay, so let's go with tangent theta, right? If you've labeled it theta, if you call it x, that's fine. I call it theta. So I'm going to go tangent theta is h over the 30. And since the angle's changing and the height's changing, that's a great equation to go with. Now, I could use sine if I wanted to, but the problem with sine is, sine, I'm going to need to know this, aren't I? Opposite of hypotenuse? I'd rather not do that. So according to this, it says find the rate of change of the angle. So what am I looking for? D theta dt. Find that rate of change when the balloon is 30 meters above the ground, when h is also 30. All right? Now, don't plug a 30 in there and go, oh, the angle's 45. I don't want to know the angle, right? I want to know the rate of change of the angle. So I'm going to show you how to do this two ways. The first way is I'm just going to take the derivative of what I see here. Second way is I'm going to solve for theta, make an inverse tan, and use my inverse tan formula. You tell me what you like the most. So right here, this is how I set it up. How do I take the derivative of tangent? What's the derivative of that? I'm still waiting. Still waiting. D theta dt. You got to get used to it. Secant squared theta, d theta dt. All right? How do I take the derivative of, and by the way, if you ever see an h over 30, I can do a quotient rule. I can go low d high minus high d low over low squared, but isn't it easier to think about that as 1/30th h? Isn't it? H over 30 is just 1/30th h. And then what's the derivative of 1/30th h? 1/30th dh dt. Now, if I did do a quotient rule, I would be going low d high minus high d low. And what is high d low? 0 over the low squared. And all that cancels, and you end up with 30 over 30 squared, which is 1/30th. So you'll get there eventually, but it's just wasting your time, I think. If you ever see, remember, that's just 1/30th h. All right, so at this point, what do? Oh, man, I got to know the angle. See, this made me have to, actually, I didn't have to know the angle. I had to know what? I had to know the secant of the angle. Now, I can know the angle. The angle's 45 when h is 30, right? Because if I plug a 30 in there, I've got a 30, 30 right triangle. That's a 45, 45, 90, right? When the sides are the same. So I know that's so I could do that and go, I could do it the hard way and go, all right, secant of 45. What's secant of 45? Well, I know it's the reciprocal of cosine of 45. I know 45 is squared, that cosine of 45 is root 2 over 2. So I know 1 divided by that is 2 over root 2. So that's what secant 45 is. It's 2 over root 2. And then I got to square it, which gives me 4 over 2, which is 2. So I can do that. Did y'all follow that misery? Now, if you didn't? Okay, how do you find secant of 45? It's a unit circle value. What do? I know that secant of 45 is the reciprocal of a cosine of 45. So I go to cosine of 45. You have to know how to do this, guys. I go to cosine of 45, which is root 2 over 2, and I flip it. And I get 2 over root 2. So you do it any way you want, but you have to know how to do that or you're going to get killed on a problem like this, which you can know all the calculus. If you don't know the unit circle, it's killing. And I'm not going to lie to you, every year, including my students, they get killed on these practice tests in May. And hopefully they figure it out. They get killed because they're like, oh, unit circle, unit circle. I don't really need to know that. I mean, oh, you're going to get hammered. It's going to take away at least a point off your score if you don't know the unit circle well. So, but listen, you don't have to know it here. Because look, what do you know about 45, 45 triangles? 45, 45 90s. 1, 1, root 2. 30, 30, 30, root 2. What is the secant of theta? If the cosine is that over that, what's secant? That over that, which gives you what? Root 2 squared. Bam. And then you didn't even need the unit circle. Are y'all tracking with me? You can find theta, or you can find the secant of theta, and then square it. But if you used inverse tan, you wouldn't have to do any of that. Talk about that in a second. So there's my d theta dt. There's my 1/30th, and then what's my dh dt? Did I not write that down? Yeah, I don't know why I did. Yeah, rises at a rate. I don't know why I didn't write that down. dh dt is 3. So I plug a 3 in there, and then I got to divide by 2 or multiply by a half to get rid of that. So when I do that, I end up with what? 1/20th? And what is theta measured in? Don't say degrees. I'd love to say degrees, but we don't do degrees in calculus. So it's got to be radians. And then time is measured in seconds. Because degrees is a man-made idea. I mean, it's totally man-made. Like, why 90? Now, radians is not man-made. Radian is basically saying how many lengths of a radius. I think we may have talked about this, but like if that's the length of the radius, how many lengths of a radius does it take? 3.14, 4, 5, 6.28. There's 2 pi lengths of the radius in a circle. So all trig using radians are real values. They make sense when you're talking about angles. So there would have to be, every time we do a derivative or an integral, if I wanted to use degrees, I would have to do this adjustment. Kind of like stoichiometry. I'd have to tweak it to make it make sense. And why do that when you don't have to? You can just use radians. Because we're Americans. Same reason we use feet and miles and not metric. Because it's like, we did it this way. It's got to be the best, but it's really.
Mr. Hurry for president. Going in metrics.
Are y'all with me, guys? Now let me show you another way where you don't even have to use trig. Check it out. If that's tangent, isn't theta equal to the inverse tan of this? So right now, if I ddx this, or dt this, sorry, d theta dt is, what's the derivative of inverse tan? It's the derivative of this. What is the derivative of 1/30th h? 1/30th dh dt over what? 1 plus that squared. And all I got to do is plug the 3 and the 30 in. I mean, I'm telling you, if you know your trig inverse formulas, your life can be really easy. Check it out. 1/30th times 3 over 1 plus 30 over 30 squared. So I get what, 1/10 on the top over 1 plus 1 squared, 2 on the bottom. And to divide by 2, you multiply by a half. So 1/20th, again, radians per second. And I don't have to do trig. I'm telling you, if you ever have to take a derivative of a trig function and you just go solve and use the inverse, I'm not saying it's always easier, but it's certainly worth a thought, especially if you get to hear and go, crap, what do I do with this? Secant? Oh, I forgot my unit circle. Now, I doubt many people forget their unit circle and remember inverse trig function rules, but hopefully you'll know it all and just you'll get comfortable with that. But I never even taught this. I had a kid do this once on a test, and I was grading it. I'm like, what the? Oh, yes, that would be much easier. Because, I mean, it was just so much extra work and extra thinking and extra evaluating and finding stuff. And they were like, why would you do that? They were right. No, I never taught show calculus. No. Taught show some derivatives and pre-calc. I didn't teach calc like that. Shows probably. Close to 40.
Oh. I think he still thinks checking his voice.
I don't know. Maybe. Just class in at 40 after?
Yes.
All right. I'm gonna let y'all handle the rest. Yeah, anybody got a particular question on anything at this point? I mean, hey, we're slowly stepping towards the test, guys. If right now your head's still spinning, come get a little help. I'm here in the mornings after school. Let's get you in a good place. All right. Come quickly this afternoon. I don't see it. I'm not going to hang around hoping you show up at 4. Might have to exit the building. Enjoy this nice, cool air outside.
Awesome.
I don't like it.
Last night felt so good.
I think it's cold in here
Yeah,
too,
mine's
so I can
right.
come in from the cold to the cold. Raise the boat.
Yeah.
Yeah, I put 100 and more than 140, probably pushing 200 pencils in that bin less than 2 weeks ago. They are all gone. And it started the year with 144 because I sharpened 144. No, I take that back. I started the year with 72, and I put more than, there was probably 100 in there. So I've gone through now 172 pencils. I don't even use pencils. So there's some serious pencil thieves.
Mr. Murray, I stole one of your pens in sophomore year and it still has ink in it.
Yeah,
I'm sorry for stealing.
I know Jack Gippen stole at least 40 pencils last year. He confessed to that. He goes, yeah, I take mine every day.
Oh my gosh, that's a problem with him.
Why wouldn't you get it out? I don't know. I mean, you say you had not giving it. If you have a 26, it might be, going crazy.
I remember putting my I just applied
Mike, for instance, I was already hitting their limit.
yeah, but I probably could it was like really
That's how I missed
You understanding everything? Get some help there?
What is it though, bro?
Yeah, you know where to find me? Oh, wait a minute. Wednesday, I think I even posted that.
Yeah. I even know, like, yeah, I'll think about it. No.
I've made it posting day.
No, it's something on this day.
I posted a lot of videos today, this week. At least a couple of them.
Volleyball.
Okay, implicit.
That's usually. Oh, so you did have Wednesday.
Implicit was Monday.
Tuesday was the super difficult one.
Derivatives of inverse. That was Tuesday. So you missed Wednesday, but you were here yesterday?
Yeah.
Was your head spinning yesterday? You need to come in and you need to go and read, listen, go and read this book. I mean, I walk you through, and you definitely need to go and read before you come in here so you have a good idea.
So I have questions.
Correct.
I know that.
Right, and if you go to, you go to implicit differentiation, page 35. It talks about, right here, implicit differentiation and related rates, page 41. You're gonna go to okay, page 51. And you want it, this is just showing you kind of the idea, but you need to go and kind of maybe read through this a little bit, but you really need to start with these guidelines and read through these. This is kind of giving you what we do, the mentality we have when we enter each problem. Read all this stuff. This is giving you some examples of how I'm finding dVdt or dsdt or whatever it is I'm talking about. And then maybe pull up a key and see how I'm setting up a couple of these. And when you do that, kind of review that, then you come in and ask the question.
I'm not reading that one, you're doing for sure. Yeah, for sure, it's a waste of time. I'll read it, I'll read it.
Well, unless you get a chance to read it.
Whoa. What's the time?
Right.
I'll try
One
it.
study?
Right. No, I'm setting phone.
Yesterday,
Well, you're gonna break.
Yeah.
I'll be here.
Yeah, thank you.
I saw him say this.
What's up, dude?
Clemson, Auburn on a Lake.
Remember to record for Dahlia today.
Already done, Lily. Yep, that's some good reminders.
Where were you?
Section.
Oh, wait, that went really well. The girl talked about free all.
Hey, is there another Bex?
Yeah.
How old's he?
He's a seventh grade.
But he's running with you guys?
He ran JV camp.
Ah,
It's all he got like top 30 in metros in the JV camp.
it's just three brothers?
Yeah.
Okay. I didn't know there was a third, and then I saw a name pop up, and I went, got him.
Yeah.
You don't see a lot of Bex. Do you know any other Bex like that are around here?
Yeah. It's like a variation on the Hungarian name, but they changed it as like Ellis Island or something like that.
Oh, yeah? Yeah, a lot of that. I think I was in an oh hurry,
Yeah.
and they tried to not look Scotch-Irish.
Keep a red hair bitch head on that one.
I was the first redhead that popped out of the family. Oh, yeah. Grandfather had black hair, dad had black hair, now dad had red in his beard. And then I'm only redheaded because my mom was a redheaded Sicilian. I mean, a Sicilian, and the Sicilians actually have red hair in their line. So me and my sister popped out with red hair. Go figure. We're the only, and then of course, all of her 6 kids have red. Well, 4 of the 6 have red hands.
Oh, I did see it. It really felt I do. I'm good, y'all.
I think
Right.
What? Oh, okay. Let me do that real
All right, guys, how are we feeling at this point? Feeling all right about it? Yes, good. Able to do the work?
Yes.
Are y'all doing the work? Yes?
I have done it every day.
All right, I'm just gonna pop around and just go from question to question. And just, I'm gonna leave a couple undone because we just aren't gonna be able to have time to do all of them. And just kind of throw stuff out. If you've got questions, please say something. Like I had somebody today go, my head's just spinning. Like I don't know what you're doing. Because he missed a day or whatever. So if your head's spinning at all and you're not seeing why we're doing something, please use today as a day to kind of figure that out. We're gonna do one more day on Monday. We're gonna take a practice quiz on Tuesday. And that's probably, and I guess it's a last minute exposure. I'm not gonna grade it, but it's actually already in your book. So don't do it ahead of time. But we're gonna do that on Tuesday, but please don't wait until Tuesday to figure that out because your test's on Wednesday. All right. So anyway, I just want to look at a couple of these. Not that one. Let's start with this. This is jumping back. We haven't done a lot of just pure implicit stuff because we've been doing related rates for a couple of days. But what do you see right here on this problem? What are they asking you for, first of all? The second derivative. What did they give you? An equation with the first derivative in it, right? So if you're finding the second derivative, can you right now take the derivative of this? You can, but it's going to be a mess. I'm just going to tell you. You're not going to be used to seeing it. You're going to have to go first d second plus second d first. You're going to have a lot of junk in there. So if you're ever taking the second derivative, and AP is trying to trip you up here. This is an old multiple choice question. They're trying to trip you up. So if you're having to take the second derivative, I strongly encourage you to avoid running into situations you're not used to seeing. I strongly encourage you to get that dy dx by itself first. Okay? So to get that dy dx by itself, I'm just going to leave that where it is. And I'm just going to divide that on both sides. And that's my second derivative. Now when I take this, so that's my first derivative. Now when I take the second derivative, it should be a little bit more palatable for me. You know what? I don't want it there. I'm going to put it over here. So now when I take the second derivative, I can do it. So how do I take the second derivative of that? Quotient rule. So low, d high. How do I take the derivative of the high? What do I get? 2 minus dy dx. Good. Minus high times d low. What's the derivative of low? Good. 1 plus 2 dy dx. So in my opinion, you've done the hard part over the low squared. Now, what did they ask you for specifically? Let me just pause for 1 second. If I had not asked you to find the derivative at this point, and I just said, if I just said that, would you be done right here? What do you have to do if it says find the second derivative and then the first derivative shows up in there? You got to take the dy dx, which is another reason why you ought to solve for that, so you have it. Take this and do what with it? Shove it in there and shove it in there. And if it's multiple choice, you probably have some simplifying ahead of you, which is not going to be pretty. And since AP is not as big on simplifying as you might think, most of the time they're going to ask you a question like this. So if they ask me about the derivative at that point, I am not going to shove that in there. What I'm going to do is make my life a little easier. And I realize that when I shove that in there, if I did, my next step would be to do what? Plug what in? Because I'm finding the second derivative. By the way, this is how you write second derivative at a point. If I haven't said this before, you draw a vertical line. If it's just an x value, you write like x equals 3. But if it's a point, I write the point there. Some people do this. Some people say d2y over dx squared, and they write parentheses xy equals 3, 0. I think that's excessive. I didn't see that in a lot of textbooks. I see it occasionally now. I don't really think that's necessary. It's okay. Obviously, it's okay because you're very clear about what you're doing. But only time I write an equal, if it's just like x equal 3, I'll write that down at the bottom. But otherwise, I'll just write x equal 3 or I'll write the point. Now think about what you would do. If I actually spent the time taking this right here and shoving it in there and shoving it in there, and then I went and plugged 3 and 0 in for every x and y, isn't that the same thing as plugging 3 and 0 in there, getting that answer and just plugging that answer in there? And that's what I'm going to do. Does that make sense? Yes, no? Don't lie to me. Does it make sense? So to me, I'm just going to go ahead and do that. Find that dx dy at 3, 0. 3 in there gives me 6 minus nothing. 3 in there gives me 3 plus nothing. So I get 2. So when I do this, it just makes it easier on me to not have to write a terrible looking equation or expression with fractions inside of fractions and it's all over the place. And then I can just go about my business. So here we go. Show me enough that I can follow your work because it's really easy to make a careless error here. Since I have 5 parentheses in this problem, I'm going to probably have 5 little values just to show the work. So here we go. Plugging a 3 in there, 3 plus nothing. Plugging a 2 in there, right? Because dy dx is 2. I get 0. Plugging a 3 in there, I get 6 minus nothing. Plugging a 2 in there, I get 1 plus 4. And in the bottom, plugging a 3, 0 in there, I get 3 plus nothing squared. So show me enough that I can kind of follow with along. Let's just kind of make sure you're in good shape. So all that goes away, and I get negative 30 over 9, which is negative 10 thirds. And then this happened to not be a calculator problem. It's pretty clear. Now, in a multiple choice question on the AP test, you don't have to show any work. Scribble away, all right? But on my test, I give points for your steps. Okay, so if you just guess, that's worth 1 point. But if this is a 5-point problem, you're going to get 1 point for circling that. You're going to get 1 point for probably finding this first derivative like it is, 1 point for finding this value, 1 point for doing, maybe even 2 points for doing the second derivative correctly. And I come in here and then 1 point for plugging all your values in there, even if you're wrong. So even if you did the math wrong, but you got everything in there, you could still get 1, 2, 3, 4, 5, and 6, even if you messed up and added wrong or something. So show me your steps. And if you skip a step, like if you do too much in your head and you're wrong, you're just losing that point and that point. So the more you show me, oh yeah, I can see that they did plug those numbers in, the better off you're going to be. All right, this is one of the more common recent AP questions I've seen on related rates. I've gotten really excited about the flag post problem. Okay, or maybe it's a flag post, maybe it's a light post, whatever. And what they have here, sometimes it's walking away from the sun. It's different things like that. But the idea is, and I don't know if you have any memory of this, but I remember being a kid and walking down this alley to this cheesy restaurant we used to go to. And as I walked past a light post, I would watch my shadow just grow. Y'all know what I'm talking about? Okay, so as the shadow's growing, now I'm walking at a certain rate, right? But the shadow is growing more quickly than my speed was. Okay, so in this problem, you have to kind of draw a picture of how this is working. So they start you off with this guy. By the way, sometimes I'll have the guy walking away, sometimes I'll have the guy walking towards. And it could be a lot of variations of this. But the bottom line is, if it's casting a shadow, we have to kind of visualize right here that the light is hitting him and casting a shadow that's that long. So we've got this diagram here that looks like similar triangles. And that's what they're trying to get you to see out of this, in addition to being able to do the calculus. All right, and I have tons of people every year that miss this, no matter how many times we do it, because they don't set the geometry up right. So let's just think through this. It says a person whose height is 6, now clearly they are not changing height, is walking away from the base of a street light, which ends up being 15 feet tall. That's not changing, so I can put that in there. That's fixed. So what is changing here? On this diagram, that length is going to change, because as I get way over here, right, I'm still 6 feet high. Right, I'm still 6 feet high, so this length right here is changing, right? This length right here is changing, but I don't even know that those are in play. But definitely the distance from the light post and the length of the shadow, those distances are changing as well, right? So I'm going to get rid of all that extra junk I just wrote up here, because I don't need any of this right here in my diagram right now. So I'm going to label this X and Y, because those are the things I don't know. So I'm going to call that length right here X, that length right there Y. So let's read through this. Blah, blah, blah. The person is walking away from the base of the light, street light, at a rate of 4 feet per second. So what am I just giving you there? So I've got dx dt, and you can label them with whatever variable. That's 4, and because I'm walking away, it's getting bigger, it's positive 4. If the guy was walking towards, it's a negative 4. And it says, what rate is the person's shadow lengthening? Well, the shadow you called y, so I'm looking for dy dt. They really don't give you any other information other than the height of you and the person in the flag post. So do you have a relationship here between X and Y that you can use? And what would you say it is? Think geometry. Great. Did you hear that? I can tell you the biggest mistake I see is this. People go, this is a mistake I'm writing. 15 over X equals 6 over Y. That's not true, because 15 over X is not the side of a triangle. What she said was 6 over Y. She's looking at this triangle and saying short leg over long leg, or whatever it is, right? Vertical leg over horizontal leg is equal or proportional to vertical leg over horizontal. And if that's X and that's Y, that's got to be X plus Y. Now, every year I'll have some poor guy or girl start taking the derivative of this. And you can, it's totally fine, but it's going to be kind of a mess. Now, remember, anytime you have an equation, you can take a derivative of it, but you can also change that equation using algebra before you get started. Might make it a lot easier on you. So rather than taking the derivative of both sides here and having to do a quotient rule or some junk like that, I'm going to go in there and just cross multiply and clean it up. And it's going to really clean up nicely. So when I cross multiply, I get 6x plus 6y equals 15y. And I'm welcome to take the derivative there, but I can clean it even more up by subtracting a 6y over and get 6x equals 9y. And I can clean it up even more if I want, by dividing both sides by a 3 or dividing both sides by a 6 or 9. Do whatever you want. But I got it to there, and I went, that's a good enough place for me to take the derivative. So if you want to divide by 3 additionally and get 2x equals 3y, great. If you want to divide by a 3, again, you can do all that stuff. But at whatever point, I'm now going to DDT both sides. And what do I get when I DDT both sides? 2 dx dt equals 3 dy dt. And I know dx dt is 4. So I end up getting 2 times 4 equals 3 dy dt. And I just divide by 3. And they happen to write the answer as a decimal, but you know that that's 2 2/3, right? Well, I hope you do. And I think this was a calculator problem, but wasn't really needed. And again, guys, you're going to make yourself, it's going to make your life a lot more difficult if I come up here and take a derivative here. If I take a derivative here, I'm going to have to go, all right, the derivative of that is what? I'm going to have to change that to y to the -1. I'm going to have to go -6, y to the what? -2 dy dt. That's a mess, right? And then over here, I can't even bring it up. I'm going to have to go low d high, that goes away, minus high d low, dx dt plus dy dt over the low squared. I mean, look what you've done to yourself. I mean, you've just created a monster problem for no reason. So my advice to you is not to do any of that stuff, right? Clean up any equation before you start. The better you can do that, the better off you'll be. All right, what about this thing? Sounds like something from a prior test. Y'all with me? Slope of the line tangent to the curve. Sounds like we're just doing a simple derivative problem, but what happens here? If I take a derivative right now, what's the derivative of y? You could, but it doesn't specify anything about time, so I'm going to dy dx it. So dy dx equals the derivative of arctan. How do I take a derivative of arctan? The easiest problem in the book, if you know your formula. It's close. I'm not going to say it's close to impossible. It's not impossible. It's much more difficult if you don't. So what's the derivative of your arctan? Remember it? So literally the last thing you do is the derivative of blah, right? That's the u prime part. That's like the chain rule. But if you can do that first on the top, that's your u. So you get 4 dx dx, which is not needed. And then the bottom, what do you get? 1 plus the u squared. So literally, if you know your rule, super easy. And then all I got to do to find the derivative at x equals 1/4 is write derivative at x equal 1/4. Please get in the habit of showing that. The AP, if you did this, if you write this statement and then do this, not on a multiple choice question, but on a free response, do you know that you lose points? Because you just said the derivative is this, and the derivative is also this. The derivative is an equation. The derivative at a certain point is that. Are y'all seeing the difference? So don't just put equals. On a multiple choice, again, do what you want. But make sure you do not join those two. These are two separate thoughts. The derivative and then the derivative at 1/4 ends up being this. And 4 times the 4th is 1. 1 squared is 1. 1 plus 1 is 2. It's super easy if you know your trig rules, inverse trig rules. How about this? How about this one? This is a 1972 problem. I know it's old. You have to dig for some of these for responses. I was 5. Parents might not even have been bored. Maybe a couple of them. Anyway, I want the derivative and the second derivative. How do you find the first derivative? Remember? The derivative is d dx. So dy dx is what? What's my rule? So copy it all down. That literally takes the derivative of the 2 and the e. Then what? And the derivative of that is negative sine x. And like I've said before, and I'll keep saying, if you're about to take the second derivative, I'd clean it up as much as you could. You don't have to, but I would. So to clean that up, I'm just going to put that, write that as a negative 2e cosine x times the sine x. So this is my second, that's my first derivative. So how do I find my second derivative? What am I going to have to do here? Product? Now, on a normal free response, you do not need to simplify. But this is such a common multiple choice question. I want to talk to you at the end of after doing the derivative about how you're probably going to see an answer. So taking the second derivative, first d second, derivative of sine is cosine x, technically dx dx, but I don't have to worry about that here, plus second derivative of the first. And the derivative of the first looks basically just like the original, but has a negative on it. So again, copy it down. Take the derivative of cosine. Now, on the free response, you can leave it like that. If that's a multiple choice question, there's no way on earth you're going to see this answer. This is what you're going to see on a multiple choice. You're going to, well, you're not going to see this step. You're going to see after this step. Right here, they're going to take these two negatives and make them positive. They're going to take the two sines and make them sine squared, and then they're going to do this. Now, you know how simplified means PEMDAS? Means go through those order of operations, and you know that PEMDAS does not have an F for factor, right? There's no reason for you to factor. But because, and you saw this a couple chapters ago, when we were taking the first derivatives, the second derivatives, we were factoring and solving to find critical numbers and inflection points and things like that. Because of that, they like to show their answers for the first and second derivative factored a lot of the time. So what you're going to see, if you get this or even this on the multiple choice and you don't see it, don't bail, because what they're probably going to do is factor out one of the x expressions. So they're going to like factor that and that out of there. And that's going to leave you a negative cosine x plus sine squared, which will probably be written like this. So just be careful that you don't bail on your answer, because your answer might be great. It just might not be in a form that it looks like. But there's no need for you to do that here if it was a multiple choice. I mean, if it was a free response. You can leave it like I have it circled. There's a balloon probably. Look at it. Oh, this is a great question too. They snuck this in on you. I'm going to go write down the original equation again, which is y equals 2e to the cosine x. Okay, see if you can figure this one out. This says if x and y both vary with time in such a way that y increases at a steady rate of 5 units per second, at what rate is x changing when x is pi over 2? What do you think are they doing differently on B than they were on A? I found the first and second derivative with respect to x on A. What does it sound like they're trying to get you to do here? With respect to time. So they're wanting you to DDT it. I can see that because it says 5 units per second. So these are varying where y and x are changing at certain rates. Their relation now is with respect to time. So they're wanting you to come up here and DDT both sides. Now, when you DDT both sides, look, you're getting dy dt, same way you got dy dx, and you're still going to get this. What's the one difference? Dx dt is typed on the end. And if you read this closely, it said y increased at that rate. So they gave you dy dt. They said find the rate at which x is changing. You need dx dt. but you need it when x is pi over 2. Well, that works out great. So I can plug a 5 in here. Now you got to know your unit circle. I was talking to the other class. If you don't know your unit circle, guys, there's no way you're getting a 5 on this test. Which I know that people go, oh, I'm not going to get a 5 anyway. Well, I don't know why not. Sometimes half the students, like we have close to half last year got 5s. I mean, it's very attainable when you spend 2 months reviewing, which we will. All right, 2 months, 3 or 4 practice tests. Make that your goal. You know, settle for a 4. Don't shoot at nothing. You'll hit that every time, right? I mean, you guys, a lot of you guys can get 5s, especially this class. This is a strong class. So shoot for that. This is not like AP US history, right, where it's really, really tough, or maybe AP Chem, where it's a hard test, but you will be very well prepared for it if you want to be, and you don't bail on me, which nobody in here has come even close to doing that. But you got to know the unit circle, or just knock a point off immediately just for that. It just shows up all over the place. So cosine of pi over 2. What's your cosine straight up? 0. What's e to the 0? 1. So far I've got a 5 equals a 2 times 1. What's the sine of pi over 2? 1. Negate it. Negative 1. And I'm solving for dx dt. So I just got to take that negative 2 and divide by it, and I get a negative 5/2. And that means relatively nothing. Oh, no, units per second. So, yeah, right, units per second, I guess, in there. All right, now, balloon problem. Okay, another very common question you see is a multiple choice question on our AP test. These are problems I use all the time on our regular test, but again, all of my questions come from variations of these. So you got this balloon that's rising from the ground. So let's make it interesting. It's a hot air balloon. Here's the ground here, and from a point, you've got this balloon is rising up, okay? So, hot air balloon rising. All right. Now it says it's rising from a point on the ground 30 meters from an observer. So 30 meters away, there's somebody observing. Now, do you remember what an angle of elevation is? An angle of elevation and angle of depression, for that matter, are always measured from a horizontal. So you look straight ahead and you basically elevate your view. So they're saying, find the rate of change of the angle of elevation. So basically, as this balloon rises, this angle is changing. Okay? So you're finding the angle of elevation, and don't quibble about things like, well, the observer is 6 feet off the ground, perhaps. No, just kind of pretend like their head is on the ground, I guess, and they're looking up. Right? So from the ground, from a point on the ground, right, that angle is changing. Now the question, so what's changing here? This length is, although I don't really see as I'm reading any mention of the line of sight's length, but it does mention height. Height's changing, angle's changing, 30 is not. Get the 30 in there. Don't call that X or something, because it is not changing. There's no rate involved in that. Now looking at this right here, is there an equation that you know that relates the sides and the angles that are shown in this figure? What is it? Tangent? Go with tangent. I mean, you could go with some other ones. You could go with sine, but then I'm going to have to know the hypotenuse. So I'm going to go tangent of the angle is the opposite h over the hypotenuse 30. Now, I'm going to start taking the derivative, and then I want to keep reading, right? It rises at a rate of 3 meters per second. What is that? What are they giving you? Good. So I know dH/dt is 3. It does tell me find the rate of change of the angle of elevation. So I'm looking for d theta dt at the moment h hits 30. Now I'm going to show you one way to do it, and then I'm going to show you another way that I never used to teach until one of my students did it on a test. I was like, ooh, that's very clever. Why didn't I think of that? So right here, if you just blindly go, all right, there's my equation, take the derivative. Totally fine, right? You can get there. What's the derivative of tangent theta? Is that it? D theta dt. It's hard to remember that. Secant squared theta, d theta dt. What's the derivative of h over 30, and how would you do it? A lot of people do a quotient rule. And I'm like, is there another way to write? And if you're like, I was going to do that, that's okay. If I go low d high, I get 30, minus high d low, I get 0, over low squared, I get 900. So I get 30 over 900, which is 1/30th, d h dt. Is there another way to do it? Yeah, isn't that the same thing as 1/30th times h? So if that's 1/30th times h, just do 1/30th dh dt. Now here's what's going to get tricky for you. What do I need to be able to solve this question? Like I'm solving for this, right? So what do I need? I need either, and I've got this other stuff. What do I need? Do I need theta? Or do I need the secant of theta? Either one's fine. Let's just say I want with theta. I need to know theta. Well, what do I know at the instant the height's 30? I got a 30-30 triangle. So what's that angle? 45? Right? If those sides are the same. So if you want that route, how do I find secant of 45? What would you do to find secant of 45? This is where unit circle stuff comes in play. Anybody? Root 2 over 2 is cosine of 45. So what's secant of 45? 2 over root 2. So you would have to find the cosine of 45, which is root 2 over 2, and flip it to get that. And that gives you, that gives you 2 over root 2. So that's the secant of 45. But then you need to do what? Square it. So you square 2 over root 2. And that gives you 4 over 2, which is 2. This is 1/10. And then the last thing you do is you multiply both sides by a half. And you get d theta dt equals 1/20th. And what would your units be? Can you say degrees? Not the calculus. So radians per second. And if you're still wondering about that, you can't use degrees. You can, but if you use degrees on any trig function, then every time you take a derivative, you have to do a conversion. Because a degree is a man-made, or it's just this random number dudes came up with, or people came up with to represent a circle, 360. Why 360? A radian means the length of the radius is measured 6.28 times, or 2 pi times across a circle. It's actually a real value that means something. So if I do things in radians, I don't have to do any conversions. So APCalc doesn't ever teach in degrees because it's just easier on you guys. Because you have to do a conversion literally every time you do a degree. I mean, every time you do a trig function in a derivative or an integral, it would mess you up. So they don't mess with it. They just go, let's just stick with radians. All right? Now, let me show you the other option. The other option is, well, what if I don't want to find theta? I just want to find the secant of theta. Well, do you remember about 45, 45, 90 triangles? They were 1, 1, root 2. So if it's 30, would it be 30, 30, 30 root 2? So what would the secant have been? If cosine's that over that, then secant is that over that, which would give you just what? Root 2, and you can plug the root 2 in there, right here, and just square it, and that gets you 2 also. But let me show you the best way to do this. Again, you're going to make it really easy on yourself if you know your inverse trig formulas. But right here, if I know I'm going to have to know theta here because my derivative has a theta in it. But if I inverse tangent this problem, when I take the derivative, I don't have theta anymore. I have what? Just the derivative of theta. But Gotta know my inverse tangent formula. But we just did one with that. So what is inverse tangent? It's 1 plus that squared on the bottom, right? And what's the derivative of that? 1/30th dh dt. And look how easy this is. I don't even need to think about it. Look, 1/30th dh dt was 3. 1 plus 3 over 30 is 1. Sorry, h is 30. 30 over 30 is 1. So I get 1/10 on the top, 2 on the bottom. And how do you divide by a 2? Multiply by a half. And there's my 1/20. And I never had to find the degree, right? If you can ever isolate a variable, and you take a derivative, the variable will not be part of your problem, right? Because it immediately goes to, unless it's theta squared or something, then you might have 2 theta d theta dt. But if it's a single variable, but you can even take care of that by square rooting both sides. It just, again, the more you isolate it, sometimes you get a really ugly equation. So you got to decide how ugly an equation on the right-hand side, but that's really not ugly if you know your rules. And I don't have to deal with secant, I don't have to deal with theta. I just have to have that memorized. And on the AP test, you only have to have memorized inverse sine, inverse tangent. Hey, while we're at it, what is the arc sine derivative? Who knows? The dx of the arc sine of u. What is it? They're all fractions. U prime on the top, under the radical. How do I, are you with me? Square root 1 minus u squared. What if it's cosine, arc cosine? Negate it. All right. What about d dx of, what about d dx of arc tan of u? We just did that, right? 1 plus u squared, u prime on the top. What do we do if it's cotan? Negate it. Arc secant. What did we get if we d dx an arc secant of u? U prime. And then what I take this basically and do what? Swap it with an additional what? Absolute value of u out front. And what do you do if it's arc cosecant? Negate it. You can get these, but all you're going to have to know is the arc sine and arc cosine and arc tangent ones on the AP test. On my test, I'll probably check you on a few of these. But then once I take that test, from there on, exams, whatever, from there on out, I just test what AP needs to know. The only reason I overdo it a little bit is because if you ever take this class again in college, you're going to need to know all of them. They don't deal with AP. They honestly, most of them think AP is beneath them, although I would say that the AP curriculum is so much better than college curriculum because those college guys, they're teaching you Cal 1 like you're going to be a math major. Like you really need to know all the theory, but most people aren't going to be math majors. Most people, 1% of those people in that class are going to be math majors. The rest of them are engineers that just need to know how to do it, you know, or they just need to check a box and take calculus to move on and get their degree in business or something like that. Hopefully, y'all won't have to take it again at all, so it won't happen. Well, I got 10 minutes. We'll do one more. All right, fishing problem. You got this guy's fishing. It says the line on a fishing pole, and I gave you a picture right here, is reeled in. So the line, right? Be careful about that. It says the line is reeled in at a rate of 1 point per second from a point 10 feet above the water. So that's the line. So what am I giving you when I tell you the line is reeled in at 1 foot per second? The dx dt. Don't make the mistake of calling this the line. That's the distance from where the line hits the water to below his pole. I don't even know what that's called. And what is that equal to? What? 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 Think about it. Why? Getting smaller. Be careful. So dx dt is -1. At what rate is the angle between the line and the water changing. So as the line's way out there, the angle's probably really small, assuming it would like be straight like this, which it's not probably, but if it was, maybe there's a fish on the end of it, making it tight. But if that angle's changing, I want to know at what rate is the angle changing when there's a total of 25 feet of line out. So when X is 25. So can you think of a relationship here that would be that would relate all this? Sine. So the sine of that angle would be the opposite, which is fixed at 10, over the hypotenuse, which is X. All right, so we'll do it two ways again. Let's take the derivative. What's the derivative of sine? Cosine theta of what? D theta dt equals. Now, I kind of like a quotient rule here. This is definitely not 10x. Right? This is 10 over x. So I'm going to go low d high, which is 0, minus high d low, which is 1, over the low squared, which is x squared, dx dt. Crap, what do I need to know? I need to know either cosine of theta or I need to know the angle so that I can find it. But if this is a non-calculator problem, let's figure it out. When x is 25, I've got a 10, 25, I don't know, call it y triangle. Can I solve for y there? Y squared plus 10 squared equals 25 squared. So I take 625 minus 100 is 525. So I get the square root of 525. So my y is root 525. So what is the cosine of theta? Adjacent over hypotenuse, right? So root, and that does clean up, but I'll do that later. X is 25, so I've got a 25 squared in there, and dx dt is -1. So before I start cleaning anything up, how do I solve for d theta dt? Multiply by the reciprocal on both sides. And then one of those 25s cancels with that. Two negatives cancel. 525. What is that? 105. 5 goes into that. 21. So I can change that to 10 over a 25 times a 5 root 21. Guess I can cancel out another 5. Again, you wouldn't have to simplify any of this unless it was a free response. But this tells me my rate of change of my angle is that many radians per second. Did you love that? I didn't. What I like is this. Rather than deal with all of that mess, I like saying theta equals inverse sine of 10 over x. And then I could just say d theta dt equals square root 1 minus that squared, and then the derivative of that, and the derivative of that again, low d high minus high low squared is -10 over x squared dx dt. And if I do that, if I know my rule and I do that, all I got to do is plug junk in. So check it out. You might think it's nasty, but -10 over 25 squared dx dt is a -1. And then the bottom, 1 minus 10 over 25 squared. So it's a little bit to simplify, but if it was a calculator problem, it would be no big deal at all. And this kind of smells like a calculator problem to me, but it doesn't have to be. but I don't have to deal with the angle, do I? So I hope you at least think about that. I give points as much as you do right. I'll give you points, and I'll have this worked out twice. But if you know your inverse trig rules, then please just learn it. Just makes your life, this test becomes so much easier for those students. They're the ones that tend to make A's, the ones that really know those formulas. All right. I'm here after school in the morning if you're still struggling a little bit. Come see me. That might have been oh, crud, no, that was Monday's work. Getting ahead of myself.
What'd you say?